All right. Hello, Mike. Welcome again.
Jack, happy Wednesday. Welcome to. Are we in our? So I had a long discussion with a friend yesterday who was very nice by asking me. He said something like, "Do you actually understand this stuff?" And I was like, "Oh yeah, I think so. I think So I got into my rambling on about things as I do, but I was like, it's tensors and it's multi. By the way, I tried to explain this, and you probably actually know the principle behind it, but I did see it, and I thought it was the thing about matrix multiplication.
Mm.
How in regular math we're taught like how to add columns of numbers, right? So here's large numbers, you have to, I don't know what it is, second or third grade, right? You're like, okay, you have to here and you carry the two, and then you do it, and then you carry the three. And when you do this, you're doing all this kind of layering of numbers to keep it simple enough to be able to not screw up your math, right? But
Yeah.
it's a kind of a cumbersome process. And then I watched this thing about matrix multiplication, whereas they figured out you can multiply numbers in parallel, large, large numbers,
Mm.
using this crazy math that was explained to me, but I couldn't really explain it, I guess. But I was like, it's so cool that you could do this. Now, am I getting this wrong? This is true, right?
Yeah, this is, well, I guess there is some kind of like easy, I guess, natural language or kind of layman's terms explanations to what's happening when you are multiplying matrices, right? So it's kind of maybe starting where natural language can be represented as a vector, right? So like a one-dimensional matrix. Like you can have a list of words in English, right? And you can say that Mike is number 150, right? And smoking is number 5,000, and cigar is number 6,000, right? So these three, this sentence now it becomes a vector, right? With Mike having a number and maybe a verb having a number and something else, right? So having that now, being this as a vector, now you can add meaning to that vector by adding another vector. Because if we kind of put, like a cup of coffee, and add it to the original sentence represented as a vector, now we have more words in that statement, right? And that's kind of a fascinating thing about language, that it can be very easily represented as a vector. So now, okay, so now the addition, right? The addition was kind of like extending a meaning. Now we have another thing that we can do, right? Which is subtraction. So we can remove the meaning from a vector, right? And then we can also do a multiplication, and multiplication works as kind of as an amplifier. So if you multiply a sentence represented as a vector by 5 maybe, then you are making it more important among other vectors, right? And the same thing you can do in converse. You can multiply, if you multiply it by a fraction, then you make it less important with respect to everything else. So now just imagine kind of doing this kind of computation with billions and billions of vectors, then things get very quickly interesting from the linguistic point of view. And maybe, the matrix has no idea about the meaning and the feeling and everything else, but the outcome is still quite interesting that you get, from those trivial mathematical operations. And that's where kind of like neural networks started, and people kind of kept adding, oh, maybe I will grab the output and put it inside, because maybe the output can amplify properly the internal, so that I'm going to get even better answer. And people start doing these kind of things, and neural networks became more and more interesting to work with us up until today, where it's really kind of amazing.
Well, for one, I'm so glad I asked you, and thank you for that great explanation. And I will just tell you this, that I'm still working on this talk, and I do have to do a very short explanation of this topic, right, to get people up to speed. I might take this and steal some of your words, by the way, but
Yeah, absolutely.
But easier than, because you're doing a talk, you always start with a joke. So the joke goes, I was in a hotel and there was a convention going on, and it turns out it was a joke tellers convention.
Okay.
So I managed to go in and peek into the joke tellers convention and saw a stage where people were coming up on stage and they would say 35, and people would be like, you know, then somebody would walk down and then another person would come up and say 152, ha, and people would laugh. And there was a person by the door and I was like, this is strange. What's going on here? And they're like, well, we know these jokes so well. We just numbered them so to save ourselves time, right? So, you know, we don't have to, like, you know, go through the whole thing. So I'm like, oh, how odd, right? And then somebody walks up and says 310, and everybody is going nuts, right? They all laugh. And I was like, well, what was that one? He was like, oh, we haven't heard that one before.
Yeah, that's cool.
So I will say, not a funny joke in any way, but an old one, and one that I've always liked. I don't know where it came from, but it's been around forever. But isn't it appropriate, right?
Yeah, very appropriate. Yeah. Yeah, that's kind of like a semantic mapping, right? Like
right. Yeah. Well, that was my next slide. Is I'm not going to go into semantics, but you know, I would love to, because it's super fun, and symbologies and everything is really interesting. Like that's its own study, and then and maybe like this conversation, like I'm not going to go into semantics, and I'm not going to go into Shannon, because we all love ourselves some Shannon, right? Something unexpected happens is always interesting, right? Especially like you said, like, hey, I didn't know this would work, said everybody, ever, right? and suddenly it does something interesting. But no, I'm going to go into physics. And so my topic for today, which we can easily get rid of because even I don't quite understand it, but the more I try to understand AI, the more I get into physics. I have no idea why, but it just starts to feel that way when you live in a universe that is quantum and quantum gravity, and the idea of unpredictability and all these sort of things have always been floating around, but they're all very useless in a Newtonian world, right? We don't care. We just want to fire bullets and do whatever we need to do and get planes to land, right? Like we live in this kind of macro world, but there's a much bigger, more macro world that we can pretty easily ignore because whatever, you know, planets, who cares? You know, so it's very human centric, but as we've seen with transformers and the mechanics you're talking about, like it's this idea of mimicking your brain, right? It mimics things that we used to think were too complicated to mimic, right? Like they were just, you know, it goes back to if you can multiply really fast huge vector spaces, right? What happens, right? Well, we never knew because we just couldn't do it that fast, and you're not going to just sit there and calculate this stuff. It's really hard, you know. But we have a little cheat, right? We have this cheat of our GPUs, you know, and they cheat by multiplying huge numbers without having to carry all the they don't have to carry the 2 or whatever, right? Like that's the fun, cute math trick that makes this possible, I guess. Okay, so the reason why I'm going to end this conversation as soon as I start it with physics is, and I think it's pronounced this way, pretty sure, right? Chirality. So and that's my new like thing about chirality in transformers. So for all our listeners, I guess, right? Chirality is this. They're exactly the same, but they aren't, right? They're actually 2 different things. One is a right hand, one's a left hand, right? So the fun chirality of the universe, as I discovered or read about, is that the universe is left-handed. It's asymmetry. Asymmetry is basically the idea, right? Like it's symmetrical, but it's not identical. So they act differently, even though they look exactly the same. So I'm going down that rabbit hole and I don't want to take you with me. But anyway, it just seems as though that the more you get into the way these things behave, so chirality, right, is the same inputs in reverse that will end up being, you see what I mean? Like this mirror, the mirror imagery part gets to be really interesting because that's kind of, like I said, it's just a bunch of numbers, right? Is 17 the same as 71? You know what I mean? Like, well, kind of, when they're a long enough string, they start to have reflections, and are reflections meaningful? So I again, I'm going to stop there because I'm way out of my depth, but it's it's sort of super interesting to see these principles at play in the natural universe, in this artificial universe that we created. I guess that's where I think it's fun.
Yeah, that's an interesting thought. I know it's been a while since I looked into this, but I vaguely remember some papers about physics and the spin of particles that they are actually, yeah, prefer to go a certain way. So yeah, there might be something to it that is kind of worth investigating. Yeah.
Well, the fun thing is we wouldn't have a universe if it was symmetry. That's the point. Like there is nothing happens in symmetry. It's imbalance that makes everything happen, right? Imbalance is causation. If everything was, perfectly even, that's the problem. Nothing ever is, So even we have these systems now, and the other thing maybe that's even more fun to talk about, and I know you have some good opinions. So at least for me, my friend was talking about this. He's saying, what about AGI, right? And my explanation was exactly that. It's like computers, and I think we disagree. So it's fine. You can tell me I'm wrong, and we'll see. You're probably right in the long term, but no, I said that they could never understand causality. I mean, the world is a non-computable problem because even we can't understand it most of the time, right? It's one person does one thing, one person does another thing, another person, like even you've heard of the three body problem, right? Like that's chirality right there. The three body problem is this thing in any kind of formation that's stable will have handedness, right? Like it will have sort of its own, because it's rare. It's really hard to do. It's hard to find something that's stable, right? Like that. And so these sort of things, sort of get mimicked in these creations that we make. And that's what I think is kind of fun, right? Because you get to play with them now, which is another one of our themes, right? As long as you can simulate it and play with it, you can learn, right? You can throw stuff at it and try to figure out like how it works and other things, which is not true of classical computers are pretty dull, right? I mean, they actually don't do anything. you know, they
Well,
require a whole lot of setup, and they have a whole lot of preconditions, right, before they
well,
get to work.
you can run a game or a spreadsheet. So I mean, there is something that you can do, right?
No, I meant, but those took a while. You remember VisiCalc? Come on, you remember probably compiling one of those long arrays that you had to type in your basic commands to get it to do Space
Yeah.
Invaders. Like here you go. Like here's a bunch of nonsensical integers that you need to write perfectly. I'm sorry, I still remember that. I'm like, God, can you imagine how long did it take for cut and paste? God, that probably took like 10 years for cut and paste, didn't it?
Yeah, I think the first cut
Oh
and paste
boy.
that I did was probably in mid 90s, maybe something like that.
Yeah. So just think about it. It just really is a house of cards, right? That you've built, and I'm just writing a thing about user experience design because I think that we've had a lot of rules and understanding that comes from old computers, right? The way computers tended to work, but they all work differently now. I don't know. Are you a Meta user? Do you use Facebook and Instagram or any of those things? Yeah.
No.
Well, I'll just say it's kind of, over a while you develop Facebook that does this thing, right? And then you have Instagram that does this thing. And what's happening now is that everything becomes very merged, right? Because this thing doesn't really do anything that this thing doesn't do. And so they've kind of, grown up in a way. So you can go to anything even brand new, like Threads, I guess, right? Was their version of Twitter. And the thing is that you can post into all of them in any of them, right? Like they don't have, there's literally no difference between them, which is funny that they have different names. And that's only a, again, it's only an artifact. Hey, they just have different names because they started out differently, but now what people do on them is so similar. I'm going to share a picture and or a video and I'm going to say something funny or whatever, right? Like that's what's interesting is that the things we do with them became very solidified. And same thing with computers, like the desktop metaphor I always thought was kind of like an old weird metaphor because we never could figure out file systems, because they're weird. And I think every time I go in to create an app, when we do the localhost stuff, I'm like always confused about like where am I? Because I'm in a command line and I'm like, okay, now I have to do everything as relative paths. Anyway, these things make my head hurt because we aren't used to using them. We have metaphors like, oh, it's a folder, inside of is a file, and here's a whatever, right? I mean, we have these conventions, and the conventions are just sort of old, right? There's nothing. In fact, I don't know if this is a better topic, but I was thinking like, sooner or later, shouldn't AI just write code that we can't read that gets the job done? Like, we don't need to read code, do we?
Yeah, I think we are getting close to that. Yeah, I think.
Okay. I mean, fine, right? I mean, most don't care, right? And in fact, I think AI kind of writes itself. Actually, I don't know because he asked me like, well, how does it get trained? And you did a really good example. You're just like, okay, here's cigar. It's 12. There you go. Once you have the map, right? So my question is if you have this map internally, it's going to digest it. You see what I mean? And then you have a model. And the relationship between the model and the training corpus, I'm assuming, is a exponentially larger training corpus and a smaller model, right? Like, I mean, it's not a direct reflection, right? It's sort of a distillation. Does that sound right?
Yeah, I agree. Yeah.
Okay, so
Well,
you can train, and as I said, you can train it on anything, right? It's just a bunch of text, as far as I know. And you can
exactly.
train it on any language of text. I don't think it cares, right? I mean, and you can train it on images and sound, right? And it's really all just going to end up in some weird
Matrix.
semantic map, right? It's just saying, hey, here's a sound, here's a color, here's a whatever. I don't care, and I don't understand it, right? And because he was talking about how he was coding with it, he's like, I just don't understand how it knows code. And I'm like, well, that's the easiest one. We have a lot of code for it to read, right? You just throw all the code you can find, and sooner or later it'll be like, oh, okay, for loops. Okay, that seems useful or whatever, but it doesn't know what a for loop is, right? It just kind of knows where it's appropriate to do it. Is that kind of its magic, right?
Well, so we always disagree on this, right? Like, does it
Yeah.
really know or not? So with the natural language like English, it is a harder problem because our statements might have many meanings, right? So there is
Yes. Okay.
polysemy, there is all those natural language, I guess, artifacts that kind of make things complex. With programming languages, the situation is totally different because each statement, each command has a very well narrowly defined meaning comparing to a human language. So a for loop will be always a for loop. It's not going to be something else like oh, I didn't mean that, right? I mean, it means it's just a allegorical expression for I don't know, adorable bunnies, right? We always, with my students, we always in my programming classes, we try to come up with interesting variable names, right? So
well, that's what I
adorable
was going to say. The variable
yeah.
names are probably the worst part, right?
yeah, but still, those programming languages are typed, right? So you have to give it the type, right? It has to be a string versus something else. So I to your point, I guess that programming was always kind of like easy target on the chopping block for automation with AI.
Well, and to your point, I mean, the language is also that artifact, right? Like, language evolves, right? And apparently I was using the word flex the other day, and it was like, oh, my kids use that word. I was like, oh, okay. I didn't know that was a but whatever. People, and in fact, youth are always kind of fun for their ability to completely make up languages because they don't want to be understood by other people, right? So these are these outliers, I guess, in a model for AI. But I think yesterday, and I shouldn't make too big of a deal about this because it might prove your point more than mine, is I really have always been afraid, or not afraid, but I don't ever think that the AI can be particularly adept at references for this reason, right? So I'm not sure. It could probably say this, but maybe as just an example, I could say, "Oh, and I want to do this, and I want to do that," and it could return say, "Oh, so it goes. Things are bad. Whatever. These are kind of ways we react to things that we don't want to deal with, right? We have axioms or something like that, right? Like we don't want to actually engage in the thing. We just want to say, yeah, whatever. But I'm doing this long piece, and it makes the film Zoolander?
Oh yeah, there was something, but yeah, maybe I've seen it, but I don't recall
It's
the plot.
okay. It was not the most well-known of movies or whatever, but it made a Zoolander reference joke. Like in context of this thing, it was it was like a perfectly good joke. You know what I mean? Like it was referencing in this topic this movie, and it was making fun of something. That's all. Like it was a kind of like it used it properly is what I meant, which was strange because I was like, that's sort of more like it saying, yeah, you shouldn't worry about that. So it goes, instead of launching into whatever AIs tend to do, right? Which is I'm going to overdo it or whatever it does, right? Um, well, I don't know. Maybe it's not significant. I'm just sort of thinking like that's really puzzling because it is super specific to a particular cultural age range. I mean, it's like you wouldn't get it, right? I could make this joke to you and you'd be like, I don't, it's like my 42 joke. It's like the 210 joke, right? Can it make a joke that I have not heard before? And that I would laugh. How's that? Maybe we can really have a cohesive discussion now, since I'm call back, right? Like if you were listening earlier in this podcast, we made this joke, but now can it make a joke? It certainly can do anything, right? It's just words. It doesn't care. It's just trying to fulfill the vector, right? I'm giving it a vector and it gives me a vector back, right? And we can perceive that as being intelligent or whatever. And that was, by the way, I guess I could throw that at. He was talking about AGI, right? And I'm like, as I said, you can't understand causality, so therefore you can never understand the real world. You can talk, but that's just like saying, Wuthering Heights predicted the financial markets or something. You know what I mean? Like it's this
But we
thing.
are the same way, Mike. I mean, we don't understand. I mean, maybe some of us do, right? But if you kind of take an ordinary person off the street and try to ask, what's the difference, between association and causality, I think 99% of the general population would, including myself, would have a hard time to actually come up with a logical explanation.
Oh, well, again, that's why I'm saying words are not always that important. But you got out of bed, you went and you did a thing, and these are all causalities, right? Like you engaged in the real world without really having to think about it. You're just like, hey, yeah, I gotta eat, so I'm gonna either. That's why I told him as my metaphor, right? Like if we didn't have stuff around us to eat, we wouldn't have a human race, but the stuff to eat is
Okay.
all around us, right? But for AI, it can't ever understand that it needs electricity, and it sure isn't going to invent it on its own. You know what I mean? Like it can't survive. So, and it shouldn't. It's just thought, right? Like thoughts are great. We love them, but they aren't actions, and actions have consequences. That's where I'm saying
Oh,
it gets
okay.
hard.
Oh, okay. So yeah, so I think you are getting into. So now better understand what you mean by causality. So what you mean by causality is a field in AI which is called planning,
Okay.
where basically, hey, I need to get out of bed or get ready for work, something like that. So there's a sequence of events or sequence of actions that has to be executed in a more or less appropriate order. And maybe it's kind of maybe I understand what I'm doing, or maybe it's just kind of going through the motions. So maybe I have my conscious level, kind of engaged, or maybe I'm so sleepy in the morning that I reach for coffee automatically. I didn't think about it, right? That kind of thing. But
Okay.
in AI, there is a very well established subfield called planning, where they are dealing with that kind of reasoning about actions, right? So there's mechanisms that involve like preconditions, available actions at a given state, post conditions and outputs that kind of go into the next step. Actually, I think that, yeah, I mean, yeah, of course the plan, you can do it on paper. Of course the plan doesn't understand that it's doing the planning, but it can be quite efficient in actually enabling you to take an action that is appropriate, right? And then understand what's the outcome of that action. And
Hmm.
then, okay, so I finished my coffee, right? Maybe now I want a donut, right? Or something, right? So AI, so I'm trying to say that symbolically, as a kind of like AI process, you can capture it, and the large language models can operate on it. So, so again, I mean,
Hmm.
probably I zeroed in on causality the way you explain this as a kind of statistical notion, but uh, but I think now you're kind of getting into the maybe that's another meeting for us to kind of discuss that,
I,
planning in the context of AI.
I mean, I'm only dismissing it into this term of AGI and probably robotics, right? Like
Mm,
you can model a system like I think generative AI right now, perfect like 4.0 or whatever, right? These new
mm,
models are really, really good because I was just using an earlier model just today and I was asking it about chirality.
mhm,
And it immediately had an answer, launched into talking about stars or protons or something, right? And I was like, no, no, I don't mean
mm,
chirality like that. I mean it in terms of AI, like how you work. And this is a self-referential thing, right? That it has been trained probably now to have self-reference, right? You need to do something is incorrect because there's no you, right?
mm.
But it translates it properly. Oh, you are a machine that does whatever you do. Like I call it a mental model. Have you ever heard of mental models? It's good
Yeah.
because I actually am writing a whole thing. I think mental models are like a real breakthrough in how we can use AIs to model different mental models, right? People think differently. It's true. And we
Mm,
rarely understand other people pretty much, right? We're all pretty unique in many ways, right? We might share certain things like a language. Hey, I understand it well. You come up to me and speak French. My biggest problem is like, well, things break down really quick, right? I don't
mm,
understand French. I could translate it, but we're still very much separated by
mm,
not being able to assess each other's. Like when I used to speak Japanese, I can barely speak Japanese, but I could tell some jokes. That
mm,
was my only thing. Like I could manage to slip in. It's like George Costanza, right? I could slip in a joke and then leave before they overload my head with talking, right? So
mm,
I could get by, right? But I certainly could not have what I would call a conversation because I'd be spending too much time translating, right? So anyway, I just sort of bring this up, I guess, in the context of this, like when you speak to AI and call it does not have a mental model of what it is. It has a model, like you just said. I get up in the morning, I need my coffee, and well, that's a model of how people act, not you. You're a computer, right? Like you need to know like what exactly. And that's why I'm saying you get into physics or you get into metaphysics, right? Because it's like it isn't a thing, right? It doesn't have a personality. It doesn't have a I don't know where agentic's going to go, but you know what my guess is people will hate agentic AI more than anything on earth, right? Because it's creepy, right? It's like robots with heads, like they don't need heads. They're robots, right? It doesn't have to resemble us. It resembles us because we trust it more if it resembles us, right? Even though none of this has anything to do with us, right? It's just more like, oh, I'm friendly here. I can use a hand. And I'm like, that's the stuff that bugs me, by the way. I just think a lot of that stuff is kind of smoke and mirrors against things that could be actually helpful and useful, in some ways. But I don't think giving AI any kind of feeling like it could know what it itself is. I guess that's the consciousness problem, right? Like, could it ever understand that? And I'm like, no,
Yeah.
I don't think it's even in the cards, right? It's a model. It's not a
It's
model of,
yeah.
yeah, or sorry. And please contradict me, because I know it's
Well,
actually hard to say. I understand.
so from the early days of AI, right? So we
Yes.
can reduce the whole discussion to the Chinese room dilemma,
Yes,
right?
Chinese room,
So
100%. I
yeah,
know. It's the
so
Chinese
so
room.
for the viewers who don't know, basically it's hey, there's a guy in a room and has cards that on one side have like an English word, on another side they have Chinese word, right? And somebody kind of asks a question, so they puts maybe a piece of paper to the guy in the room, and the guy in the room will kind of find the card that appropriate, flip it, and then give it the translation to the guy, right? So the question is, hey, does the room understand Chinese, right? And then the argument will be, hey, there is the deep arguments that there was a lot of discussions on this,
Yeah.
right? So
Oh, absolutely.
the presence of the cards with the translations, is an argument towards an understanding, right? And you can say, hey, human brain is kind of like that. I mean, it's not the cards, but yeah, we can associate, a word with in Chinese with word in English. So our translation is basically kind of like, hey, there is a guy in the Chinese room that flips the card. Our brain does it differently, but it's kind of the same output. So yeah, I think that I mean, do
Well,
we know what consciousness is, right? We don't. Roger Penrose just put out something that, hey, maybe kind of like, hey, computers will never be conscious. I think I would like to start with the definition of what consciousness is before I make that assumption, but I don't know. It has been always a big discussion.
Well, I mean, I think I can give you an example, and please feel free to say this is off, but it goes back to
Mm,
causality, right? Which is I want to go over to the store and get something to eat or something and then come back. All
mm,
right. There's nothing, I don't believe there's any particular thing about that activity that is computable, right? Like if you think about it and try to break it into the billion and one things I have to do to get up and go out and get something to eat and bring it back, right? Like there's no, you can say it verbally. I just did. I'm going to the store and I'm going to bring it back, right? Like that's all there is to say. But all the activities to break down that into actual fulfilling that is
mm,
staggering, right? Almost incomprehensible because you have to have an entire world where there is a store and blah blah blah. You know what I mean? Like you have not only that, you have directions and you have affordances. I have to step over curbs and blah blah blah, right? And so if you said robot, go to the store and get me something to eat. You're right. Like if you were a robot programmer, people, dude, or even an AI with this, you would have a really challenging set of things to do, right? Especially as you said, if your Chinese room just so happens to have a map of every surface on in this vicinity and it's really detailed, you know what I mean?
mm,
Like that's what
mm,
I think Tesla got into trouble because it didn't have actual 3D models, right? So they did the Wile E.
mm,
Coyote joke where it just assumed that something looked whatever, but it's a funny joke, right? Because like, oh wow, now you have to understand three dimensions, right? And you have to like it the problem itself becomes so huge. Of course, my feeling is, well, that's why humans are around, right? Like give them something to do. That's kind of maybe going to fetch me things from the store, but hey, I mean, it's not unknown, right? We've got DoorDash, right? So yes, it's this idea of how complex is that activity, but most of it's nonverbal and therefore non-computable in some ways, right? I mean, that's why landing on the moon was easy compared to going down to the corner to get something to eat,
Yeah,
right?
yeah, exactly. I mean, the the kind of the partial solution to the problem that you are presenting is that agentic stuff, right? So what does it mean that you have an agent versus kind of AI, right? So, I mean, AI agentic stuff, it's kind of intertwined often, but the fact that we are talking about agency means that the AI, let's say, if it finds out that it's missing information, will make an attempt to find out. Like, hey, what am I missing? What's the way, right? Maybe I need to look at Google Maps, right? Maybe I need to kind of, access some memory information about, like the staircases in your house, that kind of thing, so that the robot can be navigating those, right? So yeah, so I think people try to address those through agentic architectures, and then some people from the maybe even from I think late 90s maybe through 2000s, they were trying to address this head on through propositional logic, which
Mm.
basically would be, hey, so we're going to create a system that understands the life, the world, the physics, naive physics. They called it naive physics, right? Like, hey,
Mhm.
you don't want to bump against a table because maybe you will, your robotic knee will fail or something like that, right? So they created these kind of things to address those. So yeah, I'm not sure
Oh,
where we are
and
with
as I
this.
said, I mean, sorry to interrupt, but I'm just looking into string theory and stuff. Apparently, black holes like broke everybody's brain for like 20 years. Like somehow that's the most fascinating thing ever. And that's what's funny about science. Sometimes people just love going into the void, of whatever, where the real problem is sitting right in front of them, right? Like this is a real understandable problem, yet as you said, it probably is it's just super challenging, right? It's much
Mm.
easier to sort of go into, well, once we have fusion and once robots, sorry, AI is agentic, then somehow, or what AGI, I don't know. So what's it called? A general intelligence, awesome general intelligence, whatever AGI is. That
Mm.
then it'll just know everything, but I'm like, no, it always bottoms out, right? Every problem is usually you can make some fairly quick, if you stick to it, some fairly quick progress, and then you find it's actually much harder than you thought, and it plummets, right? Like, and I think that's where we're at now. Maybe I'm wrong, but I think AI has gotten to this thing, and then it's going to plummet because the more they try these sort of next level things, and I'm going to predict, I don't know if you don't care about Apple, but Apple threw its hand into the ring or whatever with AI, and I can tell you it's done literally nothing, right? Like it's
Mm.
barely there,
Mm.
and I think it somehow it categorizes my emails. So cool, whatever.
Yeah.
I'm like, I'm like, okay, I'm all for taxonomies. Actually, I just got a heuristic evaluation that I got GPT to do. So I was really happy about that. I'm like, yeah, this is great. If something's really tedious and not really that much value add, right? Go for it, right?
Mm.
Like that's what I love. When I was in school or whatever, automating tedious tasks is great, isn't it? Right? Like that's why we have a timer. If we could learn how it works, remember the timers on the coffee pots. So somehow in the morning you didn't have to turn on the coffee pot.
Mm. Mm.
But you're
Yeah,
right.
genius.
All these affordances aren't like that mind bending, right? They're just kind of nice. Now, if somehow it went to the store, bought the coffee, came home, somehow made it, and so when I woke up, you could say, "Thank you, agentic AI robot, for going and getting me coffee." I'm like, well, hopefully nobody's working on that, I guess. You see what I mean? Like that's way too much work to teach something to do something so easily done by humans. Or not easily. If you're a kid, by the way, going from here to the store, would probably give your parents heart attacks. Right? You know, we're like, oh my God, the world is out to get you and is going to immediately kill you if you even step foot outside the house. See, that's how bad we are with our own abilities. Sorry. Okay, I'm not going to ramble anymore, but no, I always ramble. Sorry. Thank you, Jack, for putting up with it.
Yeah, no problem. Yeah, this is something that, you know, usually sparks a discussion. So yeah, your ramblings are constructive.
Well, my hope is to at least lay out. I'm really grateful that my joke is going to land, even though it is not a funny joke. It is an appropriate joke, right? I am not going to go into agentic AI because the goal is should we stop it? And my feeling is it's going to kind of stop itself, right? It's going to be, I feel like the atomic bomb. Like once you understand its power, you kind of have to figure out how to use it, right? And the ultimate uses tend to be very much more complicated than the system itself because we're complicated. You know, we can't be expected to act nobly, right? So that's why, well, this is just a machine, right? It doesn't care if it explodes. It doesn't care about anything, right? This is just a physics problem, you know, that we managed to solve. But it just so happens that we perceive this as being and can witness it as being horrific, right? That this kind of thing would happen. And I think it's even interesting now. What are we, 50 years, right? We're 50 or 60 years after the Cold War.
Well,
Pretty
it kind
much.
of depends. Depends, you know. I
Well,
mean,
it's been a while.
the Berlin Wall, you know, is probably kind of used as a date for the ending of the Cold War, kind of, but
Well, and
maybe
we had
just a date.
Chernobyl, right? That you were, you know, we were all, or people obviously in Poland, or where, you know, they were highly affected by Chernobyl, right? Like this
Oh
was
yeah,
also
yeah,
part
it
of this
was.
thing of
Yeah.
what is this stuff, right? What is this new technology giving us, right? Is it good or evil? Are we good or evil? I'm just saying it becomes more metaphysical, even though the science is really clever, right? You know, fission's pretty clever. Um, Fusion, not clever. Sorry, not a fan. But that's for another reason. but but as we said, self-driving car, you know, we get into this other world, right? Which is good or evil, self-driving cars or blah, 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 you know, like it becomes more about how we value our own skills. And I think often, you know, our skills of being kind of nitpicky and pattern matching might be on their way out, you know. But by the way, nitpicky pattern matching really helps getting here to the store. You see what I mean? Like these are in the real world, these are really good skills to have to know that it's raining, and also that you know that the store is that way, you know, or whatever, right? Like being able to reconnoiter a real environment requires tons of pattern matching skills. And you've probably seen, at least I've seen people who don't have them. Have you seen people get lost really easily? I'm always shocked, right? Like,
Yeah, like myself, the last time I
okay,
was
well,
in
good.
Chicago.
See, you're like, is it this way or that way? Like,
Exactly.
if you don't know in a way how to reconnoiter, right? Like that skill is great to have an aid, right? Hey, I don't have to reconnoiter. The thing tells me to turn left, right? But as I said, the skills in pattern matching may have come from an event when I was a kid. I know I got abandoned by my parents because I was screwing around reading comic books when I should have been with them in the car. And so they just decided to leave. And so I had to walk home. And I can remember I'm like, yeah, I'm new to Dallas, back to Dallas, right? But I'm pretty sure we came this way, you know? And once you've kind of made your path, physically or metaphysically, if you ever go in the woods, it's a good, right? Like paths are there. Why are they there? Well, these are fairly useful ways from getting here to there, right? That's why there's a path. More than one person follows it. They're not all good, but they usually are, right? So there's this feeling of like, okay, you know, the human effect on things is positive. When you get to a place where humans are not at, the difficulty goes way, way up. right? Like it becomes very challenging to know how to climb a mountain, I think, right? Like it doesn't tell you, or maybe it does, but you have to attune into it. And I think these are all really super valuable human abilities, right? That maybe can be augmented, but never really understood by computation of any kind, right? Like it's really, really challenging. But when you see somebody do it, pretty miraculous, right? Whereas you look at a computer, it's like, hey, divide 3 by 5 or divide, multiply this 19-digit number by this 19-digit number. It's pretty miraculous. But you're like, well, whatever. It's another 19-digit number. Whatever. Seen one, you've seen them all.
Hmm.
Anyway, I know we're at time. Thanks, as always.
Yeah, thanks, Mike. Yeah, that was interesting. I think that um, your physics ideas are kind of maybe something that we can go back to.
Thank you. Well, the best thing about being not good at anything is you can always switch to another discipline and not be good at it, but good enough. Whereas honing one discipline gets really, really hard after a while, right? But the nice thing is you might see something there that helps you out, right? Because sometimes the things that are obvious aren't obvious to them.
Hmm.
Yeah. So, you're like, oh, I've been working on that problem. I just didn't call it that, right? I didn't know what a tensor was, but now it's like kind of, oh, okay, I see, right? Now it sort of makes sense. Well,
Hmm.
I don't know, but making sense is another whole different topic. Trustability in AI systems is our next topic, but either way. All right, cheers. Have a great weekend.
Yeah, thanks, Mike. You too.